In this video, we're going to look at what to do if none of the parts of the simultaneous equation are equal. So for example, in this one, I've got 3x and 1x, not the same. 2y and minus y, not the same. So what we're going to do here is use a thing called scaling. We're going to start again by labeling the equations, and then I'm going to rewrite the second equation, and I'm going to multiply it by something so that it's got one of the coefficients, either the x or the y, the same as the first equation. So let's draw a line here. I could choose to multiply equation 2 by 3, then I'd have 3x in both equations, or I can multiply it by 2, then I would have 2y in both equations. I'm choosing, because it's a little easier to work with the numbers, to double the second equation. So the first equation remains the same, but the second equation I'm going to times by 2. Now that gives me 2x minus 2y equals 6. Every part of it is doubled. So here I've doubled that bit, which would be better if I used the right tools, yeah? I've doubled that bit, so we get the 6. I've doubled the minus y's, so I get minus 2y's. And I've doubled the x, so I get 2x. They're all doubled. Let's just go back and write that 3 back in so that we can see it. Okay, so we've doubled all of those values. Now, going to look at these equations here now, these ones, and work out whether I need to add or take away. So to do that, I need to look at the signs in front of the things that are the same. The y's are the same, we've got 2y and minus 2y. The signs are different, so I'll add them together. Okay, so this line here is going to be number 1, add 2 times by 2. The blue bit of writing, you don't need to write that out when you're doing your workings. The rest of it is what you're looking for. So 3x add 2x is 5x, 2y plus 2y, add minus 2y cancels out, and 19 add 6 is 25. Divide both sides by 5, we get 5x, we get 1x, rubber, 1x equals 5. Okay, we're not finished, of course, because now we need to find out what the y value is. I'm going to substitute this back into the original number 2 equation. So 5 minus y equals 3. It's obvious that y equals 2. So then I can say x equals 5, y equals 2. That's my final solution right there. That's the answer we're looking for. Remember that the working is as important as getting the right answer at the end. Showing how you got the answer is vital. Let's clear this and try one more. Right, so we've got another equation, another simultaneous equation. This time 3x plus 2y is 19 and 2x minus 5y is also 19. The important thing that's different about this one is that we have to scale up both equations. So if we take equation 1, using the correct tool would be helpful. If we take equation 1 and times that by 2, that'll give me 6x, and equation 2 times by 3 will give me 6x. So that's my first step. I could have chosen to make the y's the same, but in this case, I've gone for using the x's. 6x plus 4y equals 38. I have times every part of the first equation by 2. The second one, 6x minus 15y equals 3 times 19 is 57. Good. Okay, now we need to decide whether we're going to add these together or subtract. So the 6x's are the same. So I need to subtract. 6x take away 6x will cancel out. If I added them together, I'd get 12x. That wouldn't help me. Okay, that's one way of looking at it. Now we need to do 4y minus 15y, sorry, 4y minus minus 15y. Remember that minus and minus gives you a plus, sort of thing. You're changing the direction on the number line. 38 minus 57 gives me minus 19. Divide both sides by 19, I get y equals minus 1. We said ages ago that negative numbers and fractions are completely allowed, so that comes up here. Okay, now we're going to take that answer and substitute that back into the first equation. 3x add minus 2 equals 19. So 3x equals 21, x equals 7. So finally, x equals 7, y equals minus 1. Solution. Good luck. Try them yourself.